Algebra 1, Common Core, Unit 3, Section 5, Advanced Trinomial Factoring. So we've learned a couple of factoring styles so far this unit. We learned about GCF factoring, difference of two squares factoring, basic trinomial factoring, and grouping. Going back to lessons, the basic trinomial factoring, that was when we had a trinomial, that was the ax squared plus bx plus c, but a was 1. The lead coefficient was 1, and we said, what adds to this, multiplies to this. The difference between advanced trinomial factoring and basic trinomial and advanced trinomial factoring is we see that we will have a number in front of x squared that is greater than 1. So that's our first time really seeing that, and it's not a GCF. That's important, because if you ever see a trinomial with a GCF, you want to start there. We'll talk about that in the next lesson on factor completely. But, so why didn't I do the video on advanced trinomial factoring right after basic trinomial factoring? Why did I do grouping in between? I did basic trinomial, then grouping, and now advanced. Well, the reason why I did grouping in the last video, where you have 4 terms and cut it in half and group it into 2 GCFs, is because the way to factor an advanced trinomial when you have a number greater than 1 for a is we're going to actually expand this trinomial to be 4 terms. And then once it's 4 terms, we're actually going to do grouping. So sometimes we refer to this as AC factor by grouping. Everyone kind of has different names for all these different things. Let me zoom out a little bit so you see more of the whole page. And so that's why we did grouping right before this, is because we are going to use grouping in this method. So the key here is, how do we turn these 3 terms into 4 terms? That's really the core of this, because once it's 4 terms, then we're just going to do grouping like we did over here, where it's just, we'll cut it in half and then GCF left, GCF right, common quotient, and I'll talk through that again. But how do we expand it to 4 terms? That's really the key. And so what we actually do, you could read this whole part on your own, but what we're doing is we're going to take the middle term. Let me switch to a different color here. We're going to take the B term, and we're going to split this into 2 things. And you notice that, this compared to this, for example, that the 3x squared stays 3x squared. The minus 2 stays minus 2. It's the middle term, the 5x, that got expanded to 2 terms. Now, what 2 terms did it get expanded to? Well, the 5x here got expanded to a positive 6x and a negative 1x. Notice that these things, if you were to combine these like terms, it would go back to be a positive 5x. So we're looking for things that add to positive 5x, just like we were looking for things that add to that middle term in the basic trinomial, except we're not looking for things that multiply to negative 2 anymore. We're looking for things that multiply to AC. And that's why this is called sometimes AC factoring. So AC, if you remember that, your first term is called the A term and your last term is called the C term. So AC means first times last, A times C. So the first thing we need to do is we need to determine the product of A and C. And in this case, that's 3x squared and negative 2. And when you multiply those together, you get negative 6x squared. And so a lot of times I'll write on the problem AC equals negative 6x squared. The x squared is definitely part of it, but really the negative 6 is the most important part, because to split up your middle terms, you need to find things that multiply to your AC and add to your B. So remember back at the basic trinomials, it was, what multiplies to C adds to B. Well, it's still kind of an AM operation, but it's not just multiplies to C. Now it's what multiplies to AC. And we use that as a reference because we look for terms, and those terms ended up being negative 1x and positive 5x. That these terms multiply to AC, negative 1x times, circled the wrong thing. 6x and negative 1x. These terms multiply to negative 6x squared, but they add to 5x. And that's what these are saying right here on this line. Right here. Let me actually see. Let me use my highlighter. That's those terms were 6 and negative 1 because the sum is 5x and the product is negative 6x squared. And so that is what we use to determine how to expand our B term. And then once we get the 4 terms, we're just going to do grouping. So slice it in half. We could take out a 3x from the right side. You're left with x plus 2. Take out a minus 1 from the right side, get x plus 2. Combine your two GCFs to be 3x minus 1 and your common quotient x plus 2. Now, when we did grouping in the lesson before, a lot of times we had dots here. You're not going to have that for these. You get dots sometimes when your highest exponent is x to the third and you get an x squared binomial. But because even though this is going to become 4 terms, it's still nothing larger than x squared. And when you do GCFs, we don't have anything with x squared in here. So we shouldn't have any dots as this process. All right, so let me do a few, start to finish. So the first thing you do for these questions is you want to determine what is AC. And just write that off to the side. What is AC? So write AC equals, and that's your first term times your last term. So 2 times negative 12 is negative 24. And it is x squared stays x squared. So I need to split this middle term into 2 numbers that multiply to this negative 24x squared and add to negative 5x. So you can say, what multiplies to negative 24x? We have, it's multiplying to a negative, so they're going to be different signs. Negative 6 and positive 4. Do they add to negative 5? No. And if I switch the signs, still won't work. Negative 8, positive 3. Do they add to negative 5? Yes. So there they are. So that means I'm going to expand this. So the first term, the 2x squared, that stays 2x squared. But this middle term gets expanded to 2 terms. And they're both going to be x and x, because they multiply to the x squared. And it doesn't matter which one goes first, either one. Negative 8x, positive 3x. And then your last term gets just brought down, negative 12. So the order doesn't matter, although some people sometimes will try to pair things up. Like they'll say, all right, I have 8 and 3. Which one do I want to pair up with 2, and which one do I want to pair up with 2? It doesn't matter. It works both ways. So either one, as long as the 8's negative here and the 3's positive, because they got to combine to be a negative 5. All right, then we group it. So down here we could take out, everything could be divided by 2, and we could always at least take out an x on the left. I'm going to be left with x minus 4 when I divide everything by 2x. On the right side, we're going to divide by everything by a positive 3. And get that common quotient, x minus 4. So the final answer, I'll just write it over here because we got plenty of space over here, is I'm going to group the 2 GCFs, 2x plus 3, and write the common quotient, x minus 4. That's the answer. Let me do another. All right, so let's see. On the right side, or, to the side of it, let me see. What is AC? First term times last term. 3 times 4 is 12x squared. So I need things that multiply to 12x squared. Multiply to 12x squared, but also need to add to that middle term. Now they're multiplying to a positive, so they're going to be the same sign, like 3 and 4. But the problem is they need to add to a negative. So if they're the same sign but adding to a negative, that means they're both going to be negative. Do these terms add to negative 13? No. How about negative 6, negative 2? Add to 13? No. Negative 12, negative 1. Add to negative 13? Yes. And so those are the ones that I'm going to use. And so I'm going to expand this. And let me actually do this over here where there's a little more space on the right. So the 3x squared doesn't change. Write these 2 terms here. So negative 12x, negative 1x. And again, it doesn't matter which one goes first, which one goes second, as long as their signs are correct. And the reason why I know they're double negative is they add to negative 13, but they multiply to positive 12. And then my C term isn't changed, so that's plus 4. Go through the process of grouping now. On the left, I could take out 3x, left with x minus 4. On the right, remember, you got to take out something. The only thing I could divide both these things by is 1 and negative 1, and I always want to take out whatever my first sign is, so I'll take out a negative 1. And that gives me x minus 4. That's good because I got that matching common quotient. So group together these. My final answer is going to be 3x minus 1 and x minus 4. All right, one more real quick. Getting to our 10-minute mark that I usually like to keep these videos around. So I'll do this one fast if I can. Got some big numbers here, but I think we can make it work. So let's see. AC. A times C. 10 times 14 is going to be 140 x squared. Now 140x squared. Right away, I'm thinking, all right, what multiplies to that but adds to 39? This one might actually take some thought. 14 and 10, I think, are the obvious ones. That doesn't work out. Remember, you could always take out your calculator. Not going to pull it up on the screen for you just because save a little bit of time here. And a good thing is you could guess and check your way through it. But if you ever go into that y equals and type 140 divided by x, and then take a look at your table, all the things that multiply to 140 are in there. That's real helpful. So I'm looking for 39, and you don't see my calculator, but I can see that 5 times 28. Well, what's 5 plus 28? 5 plus 28 is 33. So that was close. But 4 and 35, that's going to do it. It's 4 and 35. They multiply to 140, add to 39, and they're both going to be positive. So I'm ready to rewrite this. So the first term, 10x squared, and then plus. Again, you could pick either one you want. Some people might say, well, I want to do the 35 first because that's grouped with the 10, and that'll be easier to divide because I could divide them both by 5. But it works both ways. You just, basically, 3x minus 1 were the GCFs. If you had these numbers reversed, then x and negative 4 would have been the GCFs, and 3x minus 1 would have been the common quotient. So it works both ways. And plus 14. Okay, so do this real quick. Divide everything by 5x, left with 2x plus 7. Here I could take out just a 2, divide both these by, left with 2x plus 7. So the final answer then is a combination of this, group together the GCFs 5x plus 2 and the common quotient 2x plus 7. And if you ever want to check it, just go the other way. What I mean by that is this has all been a form of division. Well, I could distribute this, I could multiply it back together, and I should get my original problem. So that's how you could always check these problems, by multiplying them out to see if they get the original thing. All right, that's it. That is the advanced trinomial factoring, the most complicated factoring you're going to see this year in Algebra 1.